This is just some very quick practice with Euler's method, just so you can see that it's faster than you might think. So let's use Euler's method with 3 steps to find y0, y1, y2, y3 on the interval 1, 7, where we have the following ODE. So kind of the difference is before we started at 0, but now we start at 1. That doesn't deter us from solving this problem. So the first step is to find the step size, h, which is simply, again, the interval 1, 7 that you divide up into 3 pieces. So 7 minus 1 over 3, and that becomes 2. And it makes sense because if you want to chop up the interval 1, 7 in 3 pieces, each piece has size 2. 2, 2, 2. And then we want to find our t values. So find t0, t1, t2, t3. So again, in this picture, this is t0, t1, t2, t3. Again, you can do this either by intuition or by using the formula. So t0 is 1, and then you can use, if you want, tn is t0 plus nh is a plus nh, if you want, which is, in this case, 1 plus 2n. And that essentially gives you, again, t0 is 1, t1 is 3, t2 is 5, t3 7. And then we just want to find our yn values. Step 3. So find y0, y1, y2, y3. So again, the values at 1, 3, 5, 7. Now, y0, once again, is just the initial condition. So in this case, 3. And then I just want to remind you of the formula. Future is present plus ODE. So yn plus 1 is yn plus f of yn tn. And then you literally just have to plug in everything. So y1 would be y0 plus h of f of y0 t0, which is, again, 3 plus 2 times f of 3, 1. And that is 3 plus 2 times, again, f, in this case, I believe is our ODE, which is 1 minus t minus 2y. So 2 times 1 minus 1 minus 2 times 3. Because you see the t is 1 and the y is 3. And if you do that, you get minus 9. As follows, f of y comma t. Okay, and let's do it for y2. So y2 is y1 plus h of f of y1 t1. And in this case, we use the value minus 9. So minus 9 plus 2 times 1 minus 3 in this case, minus 2 times minus 9. And again, this gives you minus 9. And again, so 2 times 9, 18 minus 3, which is 15 plus 1, which is 16. So 2 times 16, that's 32. And that gives you 23. I know it can get quite crazy, but then y3 is y2 plus h of f of y2 t2. And again, that's 23 plus to f 2 times f of 23, comma 5, and that becomes 23 plus 2 times 1 minus 5 minus 2 times 23, and which becomes minus 77. And there's something a bit strange, actually, if you notice. That's why it's important to think critically of your work, because our values are 3, minus 9, 23, and minus 77. So if you actually plot this, of course, the plotting is optional, but still interesting. If you plot the values, again, where we at? 1, 3, 5, 7, you actually see that they oscillate like crazy. Because once again, you start with 3, I believe. So this might be 3. And then suddenly you get, sorry, wrong. So this might be a 3. And then suddenly you go to minus 9. And then 23. And then, just to exaggerate, minus 77. So it seems that the values oscillate like crazy, which is kind of an anomaly of Euler's method, which we'll discuss next time.